Okay, next we have the roller coaster problem, the second problem on this set. I didn't write a lot of stuff down because there's a lot to write down on here, so I just called it x and y and dx. So the first part, so if you remember, they gave me x, they gave me y, parametric equations for the roller coaster. They also gave me x prime and y prime, which I guess they really didn't have to do. I could have found that myself. But they gave me x prime and y prime also. So the first question was find the slope at time 2. So slope in parametric is dy dx, which is just dy dt over dx dt. So I didn't write them all down again, but dy dt, dx dt, just plugged in the 2, and I got 1.79 for the slope. Second problem said find the acceleration vector when the horizontal position is 140. So my first thing I had to do is find the time that happens. So the horizontal position had to be 140. The horizontal was 10t plus 4 sine t, that's my x. I set that equal to 140. My calculator, I just solved that. I got 13.647. Again, when I do these, I just bring this 140 over, set it equal, and find the zeros. But you can solve the equation. You can graph the intersection points, lots of different ways to do that. So 13.647. They asked me to find the acceleration vector of this. So you have two ways to do this problem. I didn't show the work on this. Acceleration is the derivative of the velocity vector. So you just have to take your x prime and your y prime. So two ways. You can take your x prime here, take its derivative, plug in 13.647, and then you get that. I get 3.329 I, because it's a vector. Take the second derivative of y, so your y prime is this one. You can take that second derivative and plug in 13.647 again. Remember, however, I think there's an easier way. You don't really have to find the derivatives. Your calculator can actually find the value of a derivative at a point. So you could just take x prime, which is the 10 plus 4 cosine t, put that in your calculator, and have it calculate the derivative at 13.647. Just going to tell you that number. And then dy dt, same thing. So you have two ways. You don't actually have to find the derivative. They're not super hard to find. The first one's really easy, little product rule on the second one. So two ways to do that, or just let your calculator do that work for you. Part C says find the time and when the car is at maximum height and find the speed. So the maximum height just occurs at the maximum y value. So you have two ways to do that. I took my y, which is 20 minus t times 1 minus cosine t, and just went to my calculator, asked it to find the maximum value for me. It was at 3.023. The other way to do it, of course, is you have the derivative also. So the maximum value is going to occur when the derivative equals 0. So you could take the derivative and set it equal to 0. You're going to get that same 3.023. And then they ask you to find the speed. So when you're in parametric, speed is the square root of dx dt squared plus dy dt squared. So I just took the dx dt, my x prime, put in the 3.023, the y prime, put in 3.023, squared them out together, got 6.03. And the last part says there are two times when the car is at ground level. Find those two times and then find the average speed between those two times. Don't evaluate the expression. So this was my y. So it's going to be equal to 0 when cosine equals 1, which is 0, but that was not my interval. Remember, it was open interval from 0 to 18. So 2 pi and 4 pi are my times when it's equal to 0. Average value of the speed. This is my speed. It's just dx dt, just like this right here, right? Speed. Dx dt squared plus dy dt squared, square root, that's my speed. To find the average of any functional value that you're trying to find, you take the integral over the time that you're looking for, 2 pi to 4 pi in this case, and then divide by the length of that interval, so 4 pi minus 2 pi, which is 2 pi. Parametric equations, some people like them, some people don't like them. Again, a difference between A, B, and BC, a little bit more parametric stuff for us. So that's it on that one.